Hi everyone. In this video today I'm going to have a look at using the Moivre theorem to solve polynomials, and I'm just going to jump straight into it. So I'm going to just solve z cubed equals I. So to do a question like this, I'm going to use de Moivre's theorem, and I'm going to convert both of these into polar form. So z cubed, now to do this we need to know that z is equal to r cis theta. So I can say that r cis theta cubed is equal to, and to put I into polar form, well, the modulus is just going to be 1, so it's 1 cis, and then the angle should be pi on 2. Now, using Moivre's theorem, we've got r cubed cis 3 theta equals cis pi on 2. So just by equating these now, basically I can see that r cubed must equal 1. And I can also see that 3 theta is equal to pi on 2. So rearranging each of these, I get r equals 1 by taking the cube root of both sides, and I get theta equals pi on 6. Now, the thing here is that when we put a number into polar form, it can repeat just by going around the unit circle, or by going around the circle more than once. And so I need to account for that and make sure to have a plus 2k pi on 3. I should have really had plus 2k pi here as well. So yeah, by having the plus 2k pi on 3 there, where k is an element of the integers, I've now accounted for the fact that we can go around the circle more than once. So what this means is that our solutions are of the form cis pi on 6 plus 2k pi on 3. And so I can basically start finding solutions just by substituting in various values for k. So I'm going to start off just with k equals 0. I think, standard procedure would be use the values of -1, 0, and 1, but I'm just going to use positive values and just convert to an equivalent negative angle. So when k equals 0, we get z equals cis pi on 6. When k equals 1, we're going to get z equals cis of pi on 6 plus 2 pi on 3. Which is going to be cis of 5 pi on 6. And when k equals 2, so we're going to get z equals cis of pi on 6 plus 4 pi on 3. Which is cis of 9 pi on 6, which is just 3 pi on 2. But, the problem there is that argument isn't a principal value. So we need to, as I said earlier, get the negative equivalent of this one. And so that's equivalent to cis of negative pi on 2. And I could show, but basically if I were to use k equals 3, that's fine, but all that's going to happen is the 3's would cancel out in this part here, and I'd end up with pi on 6 plus 2 pi, which would just be equivalent to cis of pi on 6. So there's not really any point in going any further with this problem now. So I think I've got the 3 solutions there, and so I'll just summarize and say, therefore, z is equal to cis of pi on 6, cis of 5 pi on 6, and cis of negative pi on 2. And that's all we need to do there. Anyway, I'll leave that question there and see you all later.